Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Trigonometry series and concerns the Sine Rule. This guide introduces the Sine Rule and illustrates the specific situations in when and how it can be used to solve problems involving triangles which do not contain a right angle. Introduction. Problems involving triangles are extremely common in many mathematical subject areas, including geometry, vectors, calculus and complex numbers. Many such problems involve right-angled triangles and can be solved using the trigonometric ratios. See study guide, Solving Right-Angled Triangles. You should be comfortable solving right-angled triangles before continuing with this guide. It is also common for problems to involve triangles which do not contain a right angle. To solve these types of triangles, you need to use the more general mathematical rules of either the sine rule or the cosine rule. You cannot use the trigonometric ratios or Pythagoras' theorem in these cases. The table below shows all the triangle problems that are possible and the methods you can use to solve them. If you have a right-angled triangle and you know two sides, the method you use is the trigonometric ratios. If you have a right-angled triangle and you know one side and one angle, use the trigonometric ratios. If you have a non-right-angled triangle and you know two sides and a non-included angle, use the sine rule. If you have a non-right-angled triangle and you know one side and two angles, use the sine rule. If you have a non-right-angled triangle and you know three sides, use the cosine rule. If you have a non-right-angled triangle and you know two sides and an included angle, use the cosine rule. And for any type of triangle which you know three angles, this is not solvable. The sine rule is given by lowercase a over sine of uppercase A equals lowercase b over the sine of uppercase B, where lowercase a and lowercase b are lengths of the sides of a triangle. Uppercase A is the angle opposite the side of length lowercase a, and uppercase B is the angle opposite the side of length lowercase b. This rule is often shown as a set of three equations, but this is unnecessary, as you will see in this guide's examples. This study guide only offers help with using the sine rule. There is a separate guide for help with the cosine rule. See study guide, the cosine rule. To use the sine rule effectively, you should be comfortable with the manipulation of equations and inverse trigonometric functions. See study guides, Rearranging Equations and Trigonometric Ratios, Sine, Cosine and Tangent for help with these topics. You can see from the table on the first page of this guide that you should use the sine rule to help you solve a triangle if you know the length of one side and two angles, or if you have the length of two sides and the side of an angle which is not made by them, sometimes called a non-included angle. As with all questions concerning triangles, it is a good idea to sketch the triangle you are investigating and label the quantities you know as part of answering the question. Example: finding the length of a side. Solve the triangle this. As you have one side of 9 centimeters and two angles 50 degrees and 32 degrees, you can use the sine rule by following this method. 1. You can work out the size of the third angle as you know the other two. 2. Label the side you want to calculate as lowercase a. Label the angle opposite this side as uppercase A. This is important. 4. Label the side you know as lowercase b and the angle opposite it as uppercase B. This is also important. As you know that the angles in a triangle add to 180 degrees, the size of the unknown angle is 180 degrees minus 50 degrees minus 32 degrees, which equals 98 degrees. Now label your diagram as shown in the triangle below. Here is the original triangle with the things you know already. Label the side you want to find out as lowercase a, like this. Label the angle opposite lowercase a as uppercase A, like this. Label the side you know as lowercase b, like this, and the angle opposite as uppercase B, like this. So, uppercase A equals 32 degrees, uppercase B equals 50 degrees, and lowercase b equals 9 centimetres. Putting these values into the sine rule, you get lowercase a over sine of 32 degrees equals 9 over sine of 50 degrees. Rearranging for lowercase a gives lowercase a equals 9 multiplied by the sine of 32 degrees divided by the sine of 50 degrees, which equals 6.23 centimetres to 2 decimal places. You can find the other missing side in a similar manner by labelling your triangle accordingly. See below. This is the triangle you know already, with the three angles 50 degrees, 32 degrees and 98 degrees, and the two sides 6.23 centimetres, which you have just calculated, and 9 centimetres. It only remains for you to calculate the final side. Label this lowercase a, like this. Label the angle opposite this as uppercase A, like this. Label the side you know as lowercase b. You should choose the side given in the question. So here 9 centimetres is lowercase. Finally, label the angle opposite this as uppercase B, like this. So this time, uppercase A equals 98 degrees, uppercase B equals 50 degrees, and lowercase b equals 9 centimetres. Putting these new values into the sine rule, you get lowercase a over sine 98 degrees equals 9 divided by the sine of 50 degrees. Rearranging for lowercase a gives lowercase a equals 9 multiplied by the sine of 98 degrees divided by the sine of 50 degrees, which equals 11.63 centimetres to 2 decimal places. So the solved triangle is this. Example, finding the size of an angle. Solve the triangle, this. As you have the length of two sides, 5.5 centimetres and 4 centimetres, and the size of an angle which is not made by them, 30 degrees, you can use the sine rule to solve the triangle. However, finding angles using the sine rule requires extra care. Triangles without a right angle can contain an angle which is greater than 90 degrees. Because of this, when you use the inverse sine function to find an angle, you have the potential for two answers because of the shape of the sine graph. Here, as you can see from the sketch to the left, there are two possible values between 0 degrees and 180 degrees for the angle uppercase B, whose sine is given by the sine of uppercase B. This leads to the potential for two solutions when you use the sine rule to find angles. See study guide Solving Trigonometric Equations for more details. Your calculator gives the value of uppercase B nearest to the vertical axis. You can find the other value for uppercase B by subtracting the first value from 180 degrees. If you are using the sine rule to find an angle, you need to consider each answer in turn and decide whether they provide a reasonable answer. You may find that one of the answers is not possible. However, you may find that both answers are possible and lead to two separate but correct answers. Either way, you should follow the method. 1. You know a side and its opposite angle, label the side lowercase a and the angle uppercase A. 2. Label the other side you know as lowercase b. 3. Label the angle opposite the side as uppercase B. This is important. Calculate uppercase B and work out the second value by subtracting uppercase B from 180 degrees. 5. Test the validity of both angles. So, for the example in question, you get the triangle below. This is what you know already. You know the length 5.5 centimeters and its opposite angle of 30 degrees. So label these lowercase a and uppercase A respectively. Label the other side you know as lowercase b, like this, and its opposite angle as uppercase B, like this. As you can see, uppercase A equals 30 degrees, lowercase a equals 5.5 centimeters, and lowercase b equals 4 centimeters. Putting these values into the sine rule gives 5.5 divided by sine of 30 degrees equals 4 divided by sine b. Rearranging for uppercase B, you get two possible values. Uppercase B equals the inverse sine of 0.363, which equals 21.3 degrees. Or uppercase B equals 180 minus 21.3 degrees, which equals 158.7 degrees. You can check on your calculator that the sine of 21.3 degrees equals the sine of 158.7 degrees, which equals 0.363. As you know one angle in the triangle is 30 degrees, the option of B equals 158.7 degrees is too large, as the angles would sum to over 180 degrees. So B equals 21.3 degrees, and the other unknown angle is 180 degrees minus 30 degrees minus 21.3 degrees, which equals 128.7 degrees. You can now use the method in the first example in this guide to find the missing side. Sketch your triangle. Here has included the things that we've worked, and include the things that you know already. Label the side you want to find as lowercase a, like this. Label the opposite angle as uppercase A, like this. Label one of the sides as lowercase b, like this, and the angle opposite as uppercase B, like this. These two have been chosen because they are given in the question. So, lowercase a divided by the sine of 128.7 degrees equals 5.5 divided by the sine of 30 degrees, which gives, after rearranging, A equals 8.58 centimeters. Example: if one side of a triangle is 2.5 centimeters long and the angle opposite this side is 40 degrees, what triangles can you draw if you know the length of a second side in the triangle is 2.9 centimeters? If you follow the method above, then you can work out that lowercase a equals 2.5 centimeters, uppercase A equals 40 degrees, and lowercase b equals 2.9 centimeters. You can now substitute these values directly into the sine rule to find that 2.9 divided by the sine of uppercase B equals 2.5 divided by the sine of 40 degrees. So, after rearranging for uppercase B equals the inverse sine of 0.75, which equals 48.6 degrees, or lowercase b equals 180 degrees minus 48.6 degrees, which equals 131.4 degrees. Taking the first value and using the sum of the angles of a triangle is 180 degrees gives the final angle as 180 degrees minus 40 degrees minus 48.6 degrees equals 91.4 degrees. Taking the second value gives the final angle as 180 degrees minus 40 degrees minus 131.4 degrees, which equals 8.6 degrees, which leads to two potential solutions, both of which are feasible. Either this or this. Taking the triangle on the left, you know all three angles and one side, and you can use the method in the first example in this guide to find the length of the missing side. Here is the triangle with what you know already. Label the side you want to find as lowercase a, like this. The angle opposite is uppercase A. Now choose a side and an opposite angle to be lowercase and uppercase b respectively, like this. These are chosen because they are given in the question. As lowercase b equals 2.5 centimetres, uppercase A equals 91.4 degrees and uppercase b equals 40 degrees, the sine rule gives lowercase a divided by the sine of 91.4 degrees equals 2.5 divided by the sine of 40 degrees. And you can rearrange this equation to find that lowercase a equals 2.5 multiplied by the sine of 91.4 degrees divided by the sine of 40 degrees, which equals 3.89 centimetres to 2 decimal places. Looking at the triangle on the right, you can use the same method to find the length of the missing side. Here's the triangle with everything you know labelled. So, label the side you don't know as lowercase a, like this. The angle opposite is uppercase A, like so. Now choose a side and an opposite angle to be lowercase b and uppercase b respectively. These two are chosen because they're given in the question. As lowercase b equals 2.5 centimetres, uppercase A equals 8.6 degrees and uppercase b equals 40 degrees, the sine rule gives lowercase a divided by sine of 8.6 degrees equals 2.5 divided by the sine of 40 degrees. And you can rearrange this equation to find that lowercase a equals 2.5 multiplied by the sine of 8.6 degrees divided by the sine of 40 degrees, which equals 0.58 centimetres to 2 decimal places. So there are two possible triangles which solve this question, and they are, not to scale, this triangle and this triangle. Further guidance and information. If you have any further questions about trigonometry or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.